Aircraft engine failures. Engine failure is one of the most feared scenarios for both passengers, crew, and aviation enthusiasts. Despite the dramatic imagery often associated with it, modern airplanes are designed with extraordinary safety features to handle such situations effectively. In fact, engine failure is far less dangerous than most people realize. Thanks to advancements in technology, pilot training, and engineering, the aviation industry is equipped to handle these events safely. This video explores what happens when an aircraft experiences engine failure, the procedures pilots follow, and the safety mechanisms in place to ensure the well-being of passengers and crew. Understanding aircraft engine failure. Aircraft engine failure can occur for various reasons, including mechanical issues, bird strikes, fuel starvation, or external environmental factors. While rare, engine malfunctions can happen at any point during a flight, whether during takeoff, cruising, or landing. Most commercial airplanes today have multiple engines, meaning that even if one engine fails, the remaining engine or engines can still function effectively, allowing the plane to remain airborne and, in most cases, land safely. There are two main types of engine failures: partial engine failure and complete engine failure. In partial engine failure, an engine may lose some of its power but continues to provide thrust. In a complete engine failure, the engine stops working entirely. Both scenarios require immediate and decisive action from the flight crew, but neither automatically spells disaster. Pilots training and procedures. Commercial airline pilots undergo extensive training to prepare for emergencies, including engine failure. During their training, pilots are taught to manage engine failure through simulations that mimic real-world scenarios. This rigorous preparation ensures that pilots can remain calm and follow the appropriate protocols when such an event occurs. In the case of engine failure, pilots rely on the aviate, navigate, communicate procedure, which is a universally accepted method of managing in-flight emergencies. 1. Aviate. The primary responsibility of the pilot is to maintain control of the aircraft. This includes adjusting the airplane's pitch, speed, and altitude to ensure stable flight. In a multi-engine aircraft, this usually involves compensating for the loss of thrust by making adjustments to the remaining engine or engines. 2. Navigate. After stabilizing the aircraft, pilots must determine the best course of action for reaching the nearest suitable airport for an emergency landing. Modern aircraft are equipped with sophisticated navigation systems that help pilots identify alternate landing options in case of emergencies. 3. Communication. Finally, pilots must inform air traffic control, or ATC, of the situation. They will declare an emergency, typically using the term Mayday or Pan-Pan. Depending on the severity of the failure, the pilots will then coordinate with ATC for instructions on diverting to an alternate airport or returning to the departure airport. Safety mechanisms in aircraft design. Aircraft are engineered with redundancy and safety in mind. Modern commercial airliners are designed to fly safely even if one engine fails. Most planes, especially twin-engine jets like the Boeing 737 or Airbus 320, are built to comply with ETOPS, or Extended Range Twin Engine Operational Performance Standards. ETOPS allows twin-engine planes to fly long distances over water or remote areas, provided they can safely continue to fly and land at an alternate airport with just one engine. When an engine fails, the airplane can still glide for long distances without additional thrust, thanks to aerodynamic design. Pilots can manage the descent rate and steer the plane toward a safe landing zone even without engine power. In fact, some modern jets can glide for approximately 100 miles from a cruising altitude of 35,000 feet. In-flight management of engine failure. When engine failure occurs, the immediate goal is to assess the problem and follow the checklist provided by the manufacturer of the aircraft. These checklists are designed to walk pilots through the necessary steps to either restart the engine or shut it down safely. If engine restart attempts fail, the next step is to reduce the aircraft's weight by dumping excess fuel if necessary and possible, especially when the aircraft is over its maximum landing weight. Reducing weight helps pilots achieve a smoother, safer landing. Once these adjustments are made, pilots proceed to prepare the aircraft for a controlled landing at the nearest airport. The communication between pilots and ATC is vital during this time. ATC helps reroute other air traffic to clear the plane's path, providing priority for an emergency landing. They may also offer updates on weather conditions and other factors that could impact the flight. A landing with an engine failure. Landing after an engine failure is a critical phase, but pilots are trained to handle this with precision. Even if one engine has failed, modern planes are equipped to land on a single engine. The pilot's primary focus during landing is to maintain balance and control, as losing one engine can create asymmetrical thrust. This means the plane might pull to one side due to uneven power output. As they descend, pilots perform continuous checks to ensure the airplane remains stable and aligned with the runway. If necessary, they use additional techniques such as lowering the landing gear early to create drag and help stabilize the aircraft. Most engine failures result in successful emergency landings. Famous cases such as the miracle on the Hudson, where US Airways Flight 1549 lost both engines due to a bird strike, demonstrate how effective training and design can lead to safe outcomes even in the most challenging circumstances. Passenger safety and reassurance. While engine failure might sound terrifying, it's important for passengers to remember that modern aviation has numerous safeguards in place. Pilots and cabin crew are trained to keep passengers calm, and modern planes are built to handle such emergencies. Passengers are often unaware of minor issues that pilots deal with, and in the case of an engine failure, they may only feel a slight change in the plane's power or trajectory. Pilots work to minimize passenger alarm and focus on maintaining smooth control during the event. Conclusion: engine failure, though rare, is something that modern aviation is well equipped to handle. With advanced technology, comprehensive pilot training, and stringent safety standards, planes today are more capable than ever of flying safely even in the event of an engine malfunction. While the situation may seem alarming, passengers can rest assured that aviation professionals are prepared to manage these challenges and ensure that everyone on board arrives safely at their destination.